All right, I'd like to go over what I call vector components. This is something common. Write that out. This is something common that we're going to go over in class, and it's something that really frustrates students. A vector component's really a simple concept. Let's do an example. This is something really common that you'll see in that, within the first few weeks of class. If you have a vector, let's call it vector A. Okay, and it's just exists. Okay, now when we take vectors, we usually align it on some type of oriented plane. Okay, with an x, y axis. For the sake of this class, we never go into 3 dimensions. And we've stated that, okay, this is acting on some angle, usually. All right. Now, we can have vectors that lie along one of the axes. Okay, either going perfectly horizontal or vertical. And those are kind of simple questions. When we analyze a vector, part of the problem is that we need to know how much of the vector is going in each direction. So if I have a vector that's going in just the x direction or just the y direction, then the question's been answered for itself. However, we get this situation a lot where we have vectors going at an angle. In other words, it's going in both directions at the same time. And so that causes us some issues. Now, what we do here, if this vector here, vector A, if I say that the length of A is the length of the actual arrow I drew, then I have an advantage. If I make a triangle, okay, with that vector, then if vector A, the magnitude of A, whether that be something in newtons or a velocity or a weight or a mass, whatever it may be, if that magnitude's that length, then these two side lengths, okay, really just become the vector addition to making my vector A. And we'll label these my AX and my AY. I label this side X because it's the horizontal side and it's lying along and is parallel the x-axis. My AY is vertical, and it is parallel the y-axis. So that's why I'm using x on that bottom side and y on that right side. Now, really all we do is, and I say this in class a lot, I ask, okay, give me the x and y components. When I say that, what I'm looking for that side length and that side length. I'm looking for actual numbers. In this case, I'm just using letters so that we can apply it in a variety of situations. Now, what we do here is we go sine and cosine. Those are our 2 trig functions that we're going to isolate to solve this kind of a problem. And so we have sine of our angle and cosine of our angle. Okay, let these dictate what goes with which. A lot of students, and I've said this before, a lot of students just assume that cosine goes with x and sine goes with y. And although that is a common trend, it's not the set case. Okay, sine is equal to opposite over hypotenuse. So here's my angle. The opposite side length from the angle is the AY. And the hypotenuse, that's right here. That is my A vector. And then my cosine, that's adjacent over hypotenuse. My adjacent side of my angle is my AX. And my hypotenuse there, that's that A. So if I was to solve for AX and AY, I get AY is equal to A sine theta. And AX is equal to A cosine theta. Okay, for that scenario. But let's look at another scenario. Let's say I have right here, say there's my plane. I give you this vector. We'll call this vector B. And I give you this angle right here. There's my triangle. Now if I label this is my hypotenuse. There's my right angle right there. Okay. This is my BX because this is my horizontal side. And then this right here is my BY. Okay, those are my X and Y components for vector B. Once again, you go here, go sine of theta, cosine of theta, and then you just let this speak for itself. Sine of theta states opposite over hypotenuse. So this case it's going to be BX over B. And here I'm going to get adjacent over hypotenuse, so that's BY over hypotenuse. So in this case I got BX is equal to B sine theta, and BY is equal to B cosine theta. Okay, and that's where that comes from. All right, so notice here my AX I'm using cosine, but my BX here I'm using sine. So that's an example of how you can't just assume that your X component's always going to be cosine and your Y component's always going to be sine. Okay, so let's do an example. Okay, an actual example. Let's say you have a rocket. Okay, so a rocket. I'm not going to draw it because I'm terrible at drawing. Okay, you have a rocket going at a 30-degree angle, okay, from the horizontal. We'll just say x-axis. All right, and I want to know what the X and Y components are if it has a velocity of, say, 1,000 meters per second. Okay, so what I do here is I draw my grid, draw my vector. We're going to say that's 30 degrees, and this has a length of 1,000 meters per second. Okay, so that's my V. And what I do here is I want this X portion, I want this Y portion. Okay, so I just go and I say sine of 30, cosine of 30. Okay, and I'm going to get here, I'm going to get sine of 30 is Y over 1,000. And then cosine of 30 is this X over 1,000. So my X value here, that's going to be 1,000 cosine 30. And this is going to be my Y here is 1,000 sine 30. Okay, now, a lot of the times we'd even label this as my velocity in the X direction, my velocity in the Y direction. Okay, with my overall velocity being just 1,000. Okay, let's look at another example. Let's say I have, let's do something like this, similar to our vector B. Okay, let's say this is some force acting on a free body diagram of 90 newtons. We'll give this an angle of 15 degrees. And I want to know what the force is. I want to know what Fx is, and I want to know what Fy is. Okay, the force in the X direction, the force in the Y direction. So I take that and draw over my triangle. I'm going to label this as my X, label that as my Y, and then I write out sine of theta is going to equal, let's label that as Fx and let's label that as Fy. Okay, sine of theta is going to equal opposite over hypotenuse. Okay, and my cosine of theta is going to equal my adjacent over my hypotenuse. Okay, so if I solve, Fx is equal to 90 sine 15, and my Fy is equal to 90 cosine 15. Okay, really how I'm solving for that is I'm just taking this, I'm timesing 90 to both sides. 90s cancel here and they drop over here. All right, and that's how you get those values. All right, hopefully that helps. that's going to be something that we use all year. So if you have any questions, let me know.